Hi, I'm Brian Brannon, the lead editor for IEEE Software, and I'm here today with Pooyan Jamshidi, a postdoc at Imperial College London and one of the authors on Microservices Architecture Enabled for DevOps. And he's here with James Lewis, Principal Engineer at ThoughtWorks. Pooyan?
Hello. So this is Pooyan. So the agenda for this interview is have an informal chat about our recent article that will be published in the next version of IEEE Software issue. So I'm here with James Lewis. James basically is one of the author of the famous article on microservices. So I'm sure that everybody who has done some research on microservices or they are involved in industry on microservices or DevOps have read this article previously. So thank you, James, for agreeing to have this interview. It's a very good opportunity for us to basically promote our article for a greater audience, especially those who work in industry. They don't usually read scientific articles, so it's a great opportunity for us to promote our paper. So I'm gonna start with some question and James kindly answered these questions. So I'm gonna start with a little bit of a history of microservices. So microservices, we all know that it started with SOA architecture. How the microservice itself, the term itself, has been coined, and when exactly?
Sure. Hello, everyone, and thank you very much for inviting me. It's very exciting to be on here. So, as you say, there's definitely roots going back to SOA. I'd actually go further than that and say the roots of the microservice style of building applications and building out architectures actually probably goes back 40 years to Unix, in fact. So, the idea that you have small applications that do one thing, that communicate by very simple protocols that you can chain together to produce programs that are greater than the sum of the parts, if you like, is definitely rooted in the Unix philosophy. I think the service-oriented architecture as a style promised so much, and then for some reason it seemed to get taken over by either very large consultancies or product firms who started pushing for a particular style of SOA, which involved connecting big fat services up to big expensive products, big enterprise service buses that would solve all your problems. Combined with that, I think we saw, certainly in my job, I've seen more than one 5-year, $200 million implementation of service-oriented architectures, where you sort of say, right, we will make your entire organization into an SOA organization, and it'll take 5 years and cost you all the money you've got. And at the end of it, well, actually, most of the time they kind of fail anyway, right? So I think I definitely agree that it owes a massive debt. The style to SOA, to the SOA manifesto, going back to the SOA manifesto, there's a ton of good stuff in there. In fact, they talk about the original philosophy is very, very aligned with microservices. So as I say, I agree with that. So rolling forward a bit, and this is again a standing on the shoulders of giants thing. I genuinely don't think there's anything really new in the set of characteristics, the set of practices that organizations are adopting when they're delivering software built on microservices. I think it's a case of synthesizing. It's almost like a meta architectural style, if you like, because it brings together, it synthesizes not just the componentization, breaking things down into smaller services, but Martin and I, we talked about the fact that you need to have things like teams organized around those services in a particular way, so cross-functional teams, thinking about evolutionary styles of architecture rather than upfront design, things like running how you build product teams, not project teams. So there was a whole set of continuous delivery using designing systems for failure. So all of these aspects of software that we've sort of learned how to do really over the last 15 years sort of been brought together in one place. And I think for me that's what's interesting and what makes it what's made it so successful. So I guess that's the first bit about SOA.
Yeah, but I've heard and I know that people correspond microservices with DevOps because it's a kind of first architecture style after SOA, basically. It's an instantiation of SOA, basically, if you want to say, but it has happened after DevOps. I mean, has a correspondence with DevOps practices, especially continuous delivery, these kind of new way of doing software development in novel or new organizations in an agile way. Is that true?
I definitely agree. In fact, my colleague Neil Ford, he's based in the US, he describes microservices as the first post-DevOps architectural style, in the sense that you can't really build systems this way unless you are leveraging some of the advances we've had with continuous delivery, continuous deployment, things like infrastructure on demand, elastic infrastructure. These are key enablers. Martin Fowler, another colleague, in another article, another paper, he describes the prerequisites for building out services or for building out applications in this way. And he talks about how you have to have basic monitoring. You have to be able to spin up infrastructure on demand with elastic capabilities and so on. So without, I think, the whole cultural shift towards DevOps, which I think has been driven by CI/CD squared, as it were, this becomes very, very hard. And in fact, where I see people falling over or having trouble with this style is where they aren't able to access infrastructure on demand, where they're still in the world where they're throwing software over the shelf to their operational teams and expecting them to manage things. It's one thing to throw one big application over the wall to your ops team. It's another thing to suddenly throw 600 services at them and say manage that. So I would agree. It's definitely it's definitely a key enabler of what we've been doing.
And one of the other aspects of microservices is that microservices themselves are fully stacked. So basically, they can easily provision right away, but they need some means, for example, Dockers, new unikernel, this kind of new way of, different way of hardware and infrastructure. So do you think that these kind of new technology also promoted microservices in a way?
So that's another great question. And I noticed in your paper you talked a little about this actually, and about containerization and so on. I'm not sure whether containerization per se is a prerequisite. What I think is interesting is the movement we've had away from traditionally what we'd have is a big box with a big iron application server on it. You're thinking your WebLogics, your WebSpheres, the big application servers, and we would install many individual applications into those big boxes. And generally, we would scale these things vertically. We'd get bigger and bigger boxes. What we've moved towards, I think, is away from that idea of big application server, many applications, is towards a single server with a single application running on it. So one node with one service, say, or one application. So rather than one big thing with lots of applications, it's one small thing with one application. You can do that in a number of ways, right? So you can do that, if you like, with unikernels. You can do that with containers, which obviously Docker is one sort of example of that. But when I was sort of first started building systems this way, we were just using, for example, EC2 instances. Yeah. So I don't think it's a prerequisite, say, to have containers. And in fact, the container discussion is very interesting because I think there's people are coming at containers in two different ways. One of which is to take advantage of this isolation that you need for microservices or that is useful for microservices. But also there's the big push from the operations team. If you're managing 10,000 servers, consolidating your estate into a smaller number and running multiple containers in order to optimize the CPU usage and I/O, etc. That's actually very, very powerful. So I think there's two different things with containers going on. Are they useful? Absolutely. I actually really like them for things like testing. And again, I think you talked about in your paper, in the paper, the difficulty that sometimes developers have standing up all these services locally to test them. Things like containers, or we used to use Vagrant and VMs, local VMs to do it. But being able to start up a stack of 40, 50, however many services locally as small containers, that's actually very powerful and very useful. But, yeah.
I've heard in one of your lectures, basically, that you mentioned microservices probably is not the best solution for every company. So it depends on a specific requirement. In our paper, we also mentioned our specific requirement for BlackBerry. So basically, in the paper, we reported our experience throughout this refactoring and re-architecting the previous monolithic BlackBerry to the new way of microservice-based BlackBerry, which is a backend as a service for mobile application developers. So do you think that the requirement that we mentioned, for example, the need for decentralized data governance, the automated development, these kind of stuff, scalability especially, and the way how we monitor the system, because we needed to detect the anomalies, we needed to basically have a precise, separated version monitoring data. Do you think that these are the requirements that was correct for our decision, or?
That's you've put me in a very difficult position there. It appears absolutely, yeah, that they seem perfectly reasonable. I think the point I've tried to make, and my colleagues have tried to make previously, is this is just, context is everything.
Yeah.
I talk when I do some lectures sometimes at another London university, and one of the things I sort of talk about there is the fact that there are no right answers when you come to software engineering, or very rarely are there right answers. There's only ever the slider. There are only ever sliders between one extreme and the other, if you like. So do the requirements that you state make sense from the point of view of breaking something up into microservices? Absolutely. There are a ton of others. Security is a classic example. I've been working with quite a few organizations that really like this style because they can break things up around different, very, very contained security zones. So you can do different things in different parts of your system. You're not constrained again by the lowest common denominator, which is, I think, a key sort of theme. The thing, if you've got one big monolith, everything is constrained by that one big monolith. Whereas if you break things out of it, you get to make different decisions and flex. You have different degrees of freedom in different parts of your system. So yeah, given the examples you give, I think that was perfectly reasonable. I guess when I was talking about why it's not always applicable, and I can give you an example of that, might be if you're a startup, right? So you've got a very small amount of seed capital to get going. Maybe you've invested your own money. You've got a couple of, very, very small team. And you want to get something out the door really, really fast to test and learn, to understand if there's a market or pivot or whatever. Does it make sense does it make sense in that circumstance to use a microservice style of architecture? Maybe, maybe not, right? Because there is a runway. There is a bunch of stuff you need to be able to do in order to use this, in order to build systems this way. Saying that's changing. There's platforms as a service coming out. There's lots of more support now for tooling in this space. So that might change. But it's about the technical concerns, and it's about also certainly the business and operational concerns, but whether you want to choose this sort of stuff.
Mm-hmm. You mentioned about the team kind of formation, team development around microservices. We also experienced that. So with microservices and the DevOps way of doing microservices, so basically we could organize the team around easily, a small team around each microservices separately. We can give the responsibility for each single microservices to a small team, few people.
Sure.
Maybe some of them are a member of the core team that they need to take care of the core architecture. Mm-hmm. But definitely, for example, a small team can be nicely organized microservices. So
Absolutely, yeah. I mean, we've been using this phrase internally. Another colleague, it's not stealing if you attribute, right?
Yeah.
So another colleague of mine, Ian Cartwright's got a beautiful phrase that he uses, which is there should be essentially business and architecture, business and technology isomorphism. Right, so you should be able to look, as a business person, look at the systems that you've got, the services, whatever it is, however you've built your application, and you should be able to see the business reflected in those services. Similarly, if you're in technology, you should be able to look at the world in which you live and see the business world reflecting in the technology you're building. And I think that's what we're saying. We're saying if we can bring cross-functional teams of IT, operations, all the roles that are traditionally siloed out, and business people, salespeople, and so on, into one place and have them work on these sort of smaller capabilities, then you get a much more effective working environment. You're able to deliver software faster, and that's maybe a bold claim that you can deliver software faster, but it's kind of self-evident based on essentially things like queuing theory. If work has to leave a team to get approval somewhere, you're introducing delays because you're putting a work item onto someone else's queue that they have to then process in order or whatever it is. So as a team, you're waiting for other people to do some work for you, and you're blocked until that point potentially. And obviously, you can maybe paralyze. But every time work leaves your team, you're introducing delays.
Yes.
And if you can minimize the amount of delay by introducing cross-functional teams organized around these services, these small little sets of services, then you're able, if you're able, as you suggest in the paper, I believe, to make decisions locally, then things just go much faster. It's as I say, queuing theory.
Yeah. So in this paper, one of the main contribution that we had in this paper, except reporting the experience that we had, is the catalog of migration patterns for microservices.
Sure.
So we basically documented these catalog several patterns that we think that these patterns are reusable, instantiable. We documented in a separate technical report. What do you think about that? Do you think that these are reasonable? People in industry can adopt these patterns, or is not really?
So yeah, absolutely. I'm a big fan of patterns. I've got a few caveats around this. I have opinions. Actually, usually two opposing ones, being as I work at ThoughtWorks. So for me, patterns are very, very useful when you've passed the point of novice or beginner or advanced beginner. They're a useful set of tools that you can use when you're able to understand the wider context of the world in which you live, the world of software. So, as an example, probably everyone's seen the classic "Hello World" implemented using all the Gang of Four patterns, right? I mean, I was guilty of that when I was a less experienced engineer, certainly. But then when you get older, or when you get more experience, you see more things. You realize the use of patterns. You realize that patterns are useful for what they are, which is shortcuts for communicating between people, and also tools that you can use in specific contexts. Context is king again. When certain forces are acting, that you can use potentially for your benefit. Now, obviously, I had a look at the patterns, and they all seem perfectly reasonable. I think the key for me with patterns is you only apply them if the forces are acting, and that's the difficult part, right?
Yeah.
Because if you start blindly applying patterns, you could end up with "Hello World."
Yeah, exactly.
Etc. So yeah, it seems pretty reasonable.
Thank you. So I have a kind of visionary question. Do you think that microservice architecture, this kind of cool architecture style, will sustain itself for a few more years, or you think that, for example, these unikernels architecture or new technology that has been introduced, for example, in 2016, will change the whole story?
I'll just get my crystal ball out. That's probably the hardest question you can ask me. So, I mean, I've been chatting with a few friends in the industry about some of the exciting things coming up. I think so. There's one caveat: in 5 years' time, the robots might arrive and change everything, right? Because if the robots don't like microservices, then they're going away. But at the same time, I mean, there are some actually interesting things going on. You mentioned unikernels. I've got a feeling, and I've no idea whether this will be borne out. I've got a feeling that things like Docker and containers as a technology is like a transitional step towards easily adopting unikernels. So I think there's a ton of benefits to be gained from them, but at the same time, a lot of them are still in fairly closed academic use at the moment. There's not a huge amount that I see out in the wild, but I do think they're very, very interesting. The other interesting idea is this idea of serverless architecture, which I know Amazon has been pushing with Lambda, AWS Lambda. So the idea that you don't have servers anymore, where there is somewhere behind the scenes, but that's all hidden, and you just deploy a tiny bit of code that is essentially executed in response to some event, whether that's a request or whether that's an incoming message of some description. I think that's really, really interesting. At the same time, you've got something else driving in the opposite direction, right? So I believe in the second half of this year, Amazon are going to start offering, I think they're X1 high memory instances with up to 2 terabytes of RAM per instance. Now, and initially that's going to be obviously volatile, but I think the idea is that because advances are being made in non-volatile memory as well, right? So eventually that'll become sort of non-volatile in the sort of, I guess, 18 months, 2 years time frame.
So is it because of for example, the in-memory computation, like a Spark, this kind of new way of computation, or?
That's a very good question. I've no idea what you use it for. Maybe you just create lots of very big arrays for some reason. I don't know why, but if you've suddenly got 2 terabytes of memory there, what does that mean for how we build software? What does that mean for databases, right? What does that mean for persistence, especially if that's non-volatile memory, right?
You can put everything, especially your database on memory.
Yeah.
They can.
Exactly, right. So exactly. You get around the whole problem with things like partition of graphs or graph databases because you just stick the whole thing in memory again. So there's some really interesting things happening. I think microservices is going to still be around. We're still going to be building applications in 2 to 5 years' time, right? And organizations, even if they're the sort of the unicorns of the now, are going to be much like Amazon were, facing up to the issues with things like big applications as they age, which is they get complicated, difficult to change, difficult to scale. We'll still have all those forces acting. Will everyone still be building things that are 500 lines of code long? I'm not sure. Maybe we'll swing back towards some middle ground. But I suspect a lot of people will still be building systems this way, yes.
Is there any relation, for example, the way of for example, let's say Lambda architecture with the microservices? Is there any relation, for example, because you use Lambda architecture for especially big data applications.
Mm-hmm.
So you have a stream layer, you have a source layer, you have a batch layer, and the way how you interconnect these to enable you to do lots of cool stuff in big data. So is there any relationship between the Lambda architecture and microservices? For example, let's say, can we integrate out microservices around, for example, these layers?
I don't see why not. Again,
have you seen any kind of realization of this Lambda architecture with microservices or no?
I guess yes. I guess it comes back to what I said right at the start of this, which is around Unix, right? So, essentially what we're talking about with streams is pipes and filters, right? I mean, so why wouldn't you build streams composed of pipes and filters based on microservices potentially, right? So, similarly, not specifically Lambda architecture, but we have seen in the last 2 or so years the massive rise of React and the sort of Facebook-driven React UI frameworks, but also if you look at C# and F# got RX, so reactive extensions for .NET. That's been ported to Java and many other languages as RX Java. So it seems like that reactive style, the stream processing style, is actually becoming is almost the de facto way that you build very large scale things. Okay. Now, whether you need to do that if you're mom and pop store building out a web app, or maybe you don't. If you're Netflix, they've certainly transitioned to that style. My understanding is, looking at the stuff coming out of Facebook, is potentially that they are moving there as well. So a lot of the big organizations are already moving in that direction. So it's a kind of towards an event-driven reactive approach to building software.
Yes. So basically, we are at the moment in ThoughtWorks. Do you, for example, in ThoughtWorks, do you have users that come to you and ask, okay, we need an application, we need enterprise application with microservices? I'm sure you get such kind of requests.
We do, and I'm going to put, because this is on audio only, I'm going to describe the fact that my tongue is firmly in my cheek as I say. Yes, we do get those sort of requests, and with tongue in cheek, my response is normally you can buy 10 of them, and if you buy 10, we'll throw in 2 for free. Right? You can buy 10 and get 2 for free. It is something that people ask for. It's not the sort of way we think it's appropriate to build software, though. I think not in terms of implementing microservices, but in terms of if people are asking for that sort of thing up front, then you have to ask the question: do you understand the business need?
Yes.
And you should be looking to solve the business problem rather than looking at a technology solution. It's why, for example, I tend to talk about data stores. I don't talk about specific databases. You might need a data store, but we can leave the conversation about exactly the style of that data store until later. Push that back, push that into the future. So the way we tend to go about building software is to try and work out what our customers need based on collaborative workshops, feedback, the kind of lean or agile approach to building software, without preconceptions, ideally, of what the implementation of that is going to be. I think we wouldn't be as successful as we are if we took a silver bullet approach to building software and said everyone should use this stuff. But it is becoming more frequent that people want microservices.
Yeah, because I remember when I was in industry, we used to get this kind of request that, okay, we need an enterprise application with SOA architecture. These kind of silly questions. Why you need SOA? So exactly, that's good to hear that thoughtful you hear the same questions.
It should be pointed out. I'm not here to do a sales job for ThoughtWorks, but it should be pointed out we're completely agnostic of products and suppliers and technologies as well. So we do not have any relationships, to sell preferred partners and all this kind of stuff. We're completely independent. Independent consultants.
Okay. Thank you very much for your great thoughts on microservices and especially for the great article. Actually, it was the main source of inspiration for us to write our own article. We reported the experiences that we gained through this basically refactoring the BlackTory. So I need to acknowledge basically the work of Armin and Abbas. Basically, they are the co-authors of this work, and Armin was the basically the first author of this article that has been doing this refactoring in the company that he used to work, and it was basically part of his master thesis. Thank you to you, James, as well, for kindly agreeing to do this. Thank you very much.
You're very welcome, and thank you for inviting me.
Thank you.